Good afternoon. Let us begin our lesson today. We want to look at subgroups of a multiplicative group. The other time we looked at subgroups of an additive group, Zn. That is integers mod n. Now this time we want to look at if the group is multiplicative, how do we get subgroups? So that is our mission today. Now, so to begin with, before we look at the examples, I've stated how we'll be doing that. I've said for us to determine the subgroups of a multiplicative group, the first thing we will do is to identify the members of the group, the elements of that group. That's the first thing we'll do. And we know that the members of this group are integers which are relatively prime to n. From 1 to n minus 1. So integers from 1 to n minus 1, which are relatively prime to n. So that we shall first of all find those integers. And then the second thing we'll do is to determine the cyclic groups generated by each of those integers. So we get the cyclic group generated by each of those integers. Now, those cyclic groups then are what we call the subgroups. Those will be the subgroups of this group. So I'll go through the examples. And of course, when we're writing the code, again, that's what we'll be doing. So we will have functions, one function that will be giving us the integers which are relatively prime to n. That is members of the group. Members of this group. Then we'll have another function that will now be using those members to generate the subgroups. Then of course we'll also have the main function. So at least we will have 3 functions or more to do the roles we've just talked about. And let's look at this example. Find the subgroups of Z star 12. So the first thing we said, we identify the members of this group. Elements which are relatively prime to 12 and are less than 12 and equal to 1 or greater than 1, but less than 12, relatively prime. So the first number that's relatively prime to 12 is 1, then 5, 7, and 11. Those are the only members of this group. So after identifying these members of the group, we say that the other thing now is to generate subgroups by each of these. We see this is a multiplicative group. So we take the element and multiply it a number of times until we get the identity element 1. So when we get the identity element 1, we stop. And what we have is the subgroup. Now, so when we take the first element 1, we can only multiply it once to get 1. So 1 once gives us 1. So that means 1 generates this subgroup. 1 generates, so when it generates, we put it in this bracket to mean, this bracket means the subgroup generated by the element. So the subgroup generated by 1 is this. Now, the next element is 5. 5 once is 5. 5 twice is 25. Mod 12. Mod 12. That means we divide by 12, drag the remainder. That gives us 1. Is that okay? So we've reached the identity and then we stop. We just multiplied 5 twice. 5 once gave us 5. This is 5 once, which is 5. Then 5 twice gives us 1. So that means 5 generates this subgroup. So that is another subgroup. So far, we've established 2 subgroups. The first subgroup was that of the one that has the identity element 1 generated by 1. And the other subgroup is now this. Now let's now find the subgroup generated by 7. 7 once is 7. 7 twice is 49. 49 divided by 12, the remainder is 1. So we've reached again the identity already. So it means 7 generates this subgroup. 1, 7. 7 generates this subgroup. Then lastly, the subgroup generated by 11. So again, we multiply 11 until we get the identity element. So the 11 once, and then 11 twice. So again, 11 generates that. So what subgroups have we gotten, therefore? What are the subgroups? And remember we said, when we were beginning the discussion on subgroups, we said the group itself is also a subgroup. The group itself. So for instance, this group is also a subgroup. So that therefore means that we have this subgroup, you have this other subgroup, you have this subgroup, then this subgroup. This is the group itself. This last subgroup is the group itself. So that is, those are the subgroups we have. How many are those? 1, 2, 3, 4, 5. Some cases, you will find that some elements will generate the same subgroup. So if elements generate the same subgroup, just pick one. You should not have duplicates of subgroups. So once a subgroup has been generated, that is okay. So you don't need to mention it twice. But for this case, no element generated, no two elements generated the same subgroup. No, so this is how we again create the code. So the steps are very clear. The first step is that we shall have a function to give us these elements, the elements of the group. Then we'll have a function that will be picking each of these. So I'm seeing 4 functions. The first function is just to give us the members of the group. So we'll giving us members of the group. Then we'll have a function for generating all the groups, all the subgroups. Generating all the subgroups like the one we have here. You see, these are all the subgroups. But before it does this, there must be one that generates a single subgroup at once. So that this one, the one that is generating all the subgroups, asks some function to generate a subgroup generated by 1. Then it will ask, generate now a subgroup generated by 5, and so on. So therefore, and then we have the main function. So those are 4 functions. Those are the ones, but of course you can always want to have one function performing several roles. You just give it and it will perform those roles. Now, let's look at another example before we go to how to use the code. Now, so we have a function that is giving us the elements here, the elements which are relatively prime to 15. And that function tells us we have 1, we have 2, we have 4, is it? 3 is not, 5 is not, 6 is not, we have 7, we have 8, 9 is not, 10 is not, 11, is it? 12 is not, 13, then lastly, 14. So we have a function that will be giving us all those. Then we have a function that will now be giving us what 1 generates, what 2 generates, what 4 generates. And if there are duplicates, last time we said we shall have a hash set that will now be saying if there are duplicates, it removes those duplicates. And like we see in the results I have here, there are some elements which are not here. It means they generate the same subgroups that we already have. Generates the same subgroup. Let's see. 1 generates, just multiply 1 once and you get 1. What about 2? 2 once is 2. 2 twice is 4. 2 3 times is 6, is it? 8. 8, eh? Then multiply 4 times. That means 8 times 2, which is 16. We are doing it mod 15. That gives you 1. So that is the subgroup generated by 2. Is that okay? Let's check 4. 4 once is 4. 4 twice is 16. We are doing it mod 15, and this gives us 1. So we've already reached the identity element. That means 4 generates that. 1, 4. Is that okay? Let's look at 7. 7 once is 7. 7 twice is 49. If 15 were to go there, we'd get 45 somewhere. That would be 4. Because 15 will go there 3 times. Is that okay? Then 7 3 times. 7 3 times. We already have 7 twice. 7 twice, we have it as 4. So 4 times 7 will be 28. So this is 28. And we are doing it mod 15. So if 15 goes there once, the remainder is 13. And then 7 4 times now will be 13 times 7, which is 91. 15 goes here 6 times. And you get 90, the remainder is 1. So that is a subgroup generated by 7. Yes. Now, what about, we are done with the 7, let's go to 11. Want to see what subgroup 11 would generate. So again, just the same procedure. 11 once is 11, and 11 twice is 121. We are doing this mod 15. How many times does 15 go there? What's the remainder? Because how many times? 8. And the remainder is? The remainder is 1. So this is the subgroup generated by 11. Now 13 I've not included it. Let's see. My reason will have been because it was generating a subgroup we already have. So if it's generating a subgroup we already have, we don't need to have the same subgroup twice. And let's see which subgroup it was generating. 13 once, 13, 13 twice, 169. We are doing this mod 15. What's the remainder? Yes. What's the remainder there? Hmm? 4. Okay. Then 13 3 times. 13 3 times. It will be the same as 13 twice times 13. But 13 twice, you already have it as 4. And then that is 13, which is what? 52. Is that okay? Mod 15. Mod 15. And that gives us what? 15 goes there. Is it 3 times? Yes, because of 45. Is that okay? And the remainder will be 7. The remainder will be 7, and that is the 7 we are seeing there. No. Yes, yes. Okay, so we have said that it has generated 13, it has generated 7, and it also generated 4 there. Okay. Now, so what about 13 4 times? This will be 13 thrice times 13. But 13 thrice is what you just told me, 7. So this would be 7 times 13. This is 91. Is that okay? That's 91. Huh? 7 times 13. Mod 15, that gives you a remainder of what? Is it 1? 1. So that is why I did not include 13, because it was giving the same subgroup as the one generated by 7. Is that okay? So there was no need of having the same subgroup appearing twice. Now, so let's look at the subgroup generated by 14. The subgroup generated by 14. So again, we multiply 14 several times until we get the identity element. The first time we multiply 14, just multiply it once. That gives us 14. Then 14 twice. 14 twice. What is the answer? 14 times 14? 196. Huh? 196, huh? Mod 15. Mod 15. 1. So 14 generates itself and then 1. So that is a subgroup. This is a subgroup generated by 14. The other subgroup is the group itself. The group itself. So how many subgroups are we talking about? 1, 2, 3, 4, 5, 6, then 7. The group itself. So I think when I was writing my notes, there are some subgroups which are not appearing this side. So the last two subgroups, I think they're missing here. But that is how you get subgroups of a multiplicative group. I'll do the last example for that, and then we'll look at how to write the code. And of course, we've already seen the types of functions we require in that code, what we'll be doing, what each of the functions will be doing, so that we come up with the subgroups. Now, so we want the subgroups of Z star 18. Subgroups of this. So we'll have a function that is giving us the elements of this group. So the elements of this group, 1 is 1. Those which are relatively prime to 18, 1. 2 is not. 3 is not relatively prime to 18. 4 is not. 5 is. Is it? 6 is not, but 7 is. 8 and 9 are not. 10 is not. 11 is. 12 is not. 13, 14, 15, 16, 17. Is that okay? Those are the elements relatively prime to 18, is it? Yes. I want to see the subgroups generated by each of them. Begin with 1. We multiply every element several number of times until we get the identity. But you note that 1 will be only multiplied once, and you have the identity. So that means that 1 generates this subgroup. 1 generates that subgroup. Then we check 5. Check 5. 5 once is 5. 5 twice is 25. Mod 18, that is 7. Is that okay? 5 thrice is 5 twice times 5. 5 twice is 7 times 5. That is that 5. Is it? That 5 mod 18. If 18 was going to that 5, the remainder will be 17. Is that okay? The remainder will be 17. If 18 was going to that 5, the remainder will be 17. 5 4 times, 5 3 times 5. But 5 3 times is 17. Then times 5, this gives us 85. We are doing it mod 18. We are doing it mod 18. So if 18 were going to 85, the remainder will be 13. The remainder will be 13. So we've generated 17, generated 13, we had generated 5. Okay. Now 5 times will be 5 4 times 5. 5 4 times we've said is 13 times 5. This gives us 65, and we are doing it mod 18. Finally, not finally, I think we still have some to go. 5 6 times, 5 5 times 5, which is 11 times 5, which is 55. We are doing it mod 18. One. Had we gotten 7? Oh, we got 7 when we did 5 twice. When we did 5 twice, we got 7. So that means 5 generates this. That's subgroup. What about 7? I left it out. I think 7 will generate either the second or the last. The one of these two, the ones that have 7, generate either the first or the second or the last. Let's see which one it generates. So 7 once will be 7. 7 once will be 7. 7 twice will be 49. Mod 18. Is it 11? 13, huh? Okay, so it's generating this one. Read this group. Let's see. 7th rise, 13 times 7, which is 91. Mod 13, no, mod 18. Hmm? 1. Oh, it gave us 13. It given us 7. Now has given us 1. So it's generating this one. It's generating that one, not the last one. So 7 generates the second. So we have several elements which will generate the same, they'll be generating the same subgroup. And that is why we have few subgroups as compared to the number of elements. Also, you have some which are generating the same subgroup. Okay, and so on, and so on. We try 11 and 13, 17, but these are the only subgroups that will be generated by this group. Those are the examples I wanted to look at, and then we go to the code. We need to understand the code, how to write it, and then how it works. I'd already said that this code will have a point where, first of all, so the code, I have this part for the GCD. This part is, first of all, to find out which elements are relatively prime to n. Which elements are relatively prime to n. Because the elements which are relatively prime to n are the members of this group. Are the members of this group. So look at this part and then this part. These two, the first one, once we have Zn, once we have Zn, what the first one is doing is just getting the GCD of the elements of Zn. Because Zn has 0, 1, 2, 3, 4, all the way up to n minus 1. So what the first one is doing is just find the GCD of all those elements. Is that okay? The second one is now filtering, and you can see it's using what has been obtained from above. What has been obtained from above is now filtering, is now picking only those which are relatively prime and storing them here. And you can see it saying, if the GCD is 1, if the GCD is 1, now collect there. Is that okay? So this one just found the GCDs. Just found the GCDs. And then this one now collects the ones which are relatively prime. In other words, those which now belong to the group. This is the one which is, and I've called it multiplicative group elements. Multiplicative group elements. The elements of the multiplicative group. Is that okay? And we understand that elements of the multiplicative group are those elements which are relatively prime to n. So these two are doing different jobs, and we need to understand what they are doing. Of course, you know the calculations going on. Calculations going on at every step. This one does. There are no calculations at this point. There are no calculations at this point. What it's just doing, what this one is doing, it knows that if you're talking about, for instance, Z5 star, it knows that elements are ranging from 1 to n minus 1. Is that okay? So those elements from 1 to n minus 1, it is filtering those which had a GCD of 1 with the n. Those elements which had GCD of 1 with the n, just filtering from the solutions from above. Solutions from that point. Is that okay? We're just filtering and storing them here. So for instance, supposing this was 8. Supposing this was 8, we know that our elements will be 0. All the elements, suppose, let me remove the stuff first of all. Let me remove the stuff first of all. Supposing it was just Z8. Supposing it was just Z8. So the elements this one has are 0, 1, 2, 3, 4, 5, 6, then 7. Those are the elements this function has. So this function, therefore, at this point, it's entering, so B will then stand for n. B would stand for n, and A will stand for these elements. So it will find the GCD of 0 and 8. That will be 8. We find the GCD of 0, 1, and 8. That will be 1. We find the GCD of 2 and 8. That will be 2. The GCD of 3 and 8, that will be 1. The GCD of 4 and 8, that will be 4. Is that okay? So this one just finds those GCDs. And then this one will now be picking from those GCDs. Which numbers from these numbers, all these numbers, which ones gave GCD of 1, then store it here. That is what was true. That's what was true. Unless somebody wants for me to explain how the GCD is obtained at this point, I wanted to avoid that because we've done it before. But this is what the function is saying. The function is saying that if B is 0, then the GCD is 1. That's what the function is saying. If B is 0, then the GCD is A. Is that okay? What that means, supposing you had input 8 and 0, and you're finding the GCD. So in this case, our B is 0, and our A is 8. The GCD becomes A. That's what the function is saying up to here. This function is saying that up to here, at this point. Then it continues and says else. Else means if B is not 0. Is that okay? If none of the elements is 0. Is that okay? If none of the elements is 0, then this is how you compute the GCD. That's what the function is saying. That is how do you compute the GCD? Now, supposing now we have 8 and 4. Let me say even in the 2. Is that okay? And we want to get the GCD. What it's saying, what this is saying, is that you make a call for B and the remainder of A on division by B. The remainder, this is what that means. A with this, it means you write the remainder when A is divided by B. So you make a call for B and the remainder of A on division by B. Is that okay? Now, so if this A is divided by this B, the remainder is 0. Is that okay? Now, One of the elements is now 0. One of the elements is 0. This is what it says. If one of the elements is 0, the GCD is that element which was not 0. Is that okay? So in this case, this call, one of the elements is 0, and therefore the GCD automatically becomes 2. And that's the GCD of 8 and 2. That's the GCD. That's how we do it. That's how this part is saying. Let me use a number that is not 2, because 2, it was very easy to do that. Let me use 4. 8 and 4. Let me use 8 and 4. So that we understand these steps, what these steps are saying. Is that okay? Supposing I want to get the GCD of 8 and 4. So this part does not apply to us at this point. None of the elements is 0. Is that okay? So we go straight to else. And the else says, you make a call to find the GCD of B. So in this case, this is my A, and this is my B. So I now make a call for B. Is that okay? Make a call for B, and the remainder of A on division by B. Is that okay? Once one of the elements is 0, I can apply this part. The GCD becomes 4. Is that okay? I've used very easy elements. Let me use one that are, those that are not easy. Let me use, these ones are very easy. They were just giving us one step. One step. Let me think of, okay, let me think of GCD of, let me say 16, 24, and 8. Now this will be easy. 24 and 15. Yes, this is okay now. So that we go more than one step. Huh? So in this case, my A is this and my B is this. So the first part does not apply, but what applies is beginning from else. And what it says, you make a call for the GCD of B and A, the remainder of A on division by B. My A is 24. When I divide that by B, what is the remainder? 9. 9. Good. Is that okay? Yes. We do this until we get one of the elements becoming 0. Is that okay? So, none of the elements is 0, so we proceed. We proceed and make another call. B is now 9. Is that okay? And A is now 15. 15 divided by 9, the remainder is 6. We do this until we have the remainder of 0. Is that okay? Make another call because none of the elements is 0. So make another call. This time our B is 6. And the remainder of 9 on division by B is 3. Is that okay? Yes. Then make another call. This time our B is 3. Is that okay? And the remainder of 6 on division by 3 is 0. Huh? We've achieved our mission. Our mission was that we do that until B becomes 0. Until B becomes 0. And when B is 0, we come back here. A is the GCD. And therefore, that means our GCD, therefore, is 3. Is 3. So that is how we do, that is how this function is calculating the GCD. That's how it is calculating the GCD. This is the division algorithm. Now, so this first function, that is its role. It will be doing GCD for each of the elements mod n. Each of the elements mod n. Once it has done the GCDs, the second function here is just to pick those which gave the GCD of 1 and store them here. Its role is done. Is that okay? Its role is done. Now, so this one will work, this one will be doing its work last. This one says generate subgroup. It's just generating one subgroup at a time after it has been requested. Which one is requesting? The one that is requesting is this one. This is the one which will be requesting. It will be telling it, supposing we want the subgroups of Z star 8, and it knows now from this one has already listed the elements which are relatively prime. It has already listed 1, it has listed 3, it has listed 5, it has listed 7 as the elements which are relatively prime to 8. So this will be asking it, I want the subgroup generated by 1. Is that okay? So once it's told that, it does for 1. Then this one again asks, I want the subgroup generated by 3. Then it does. Is that okay? I want the subgroup generated by 5. Then it does. And as it does, this one stores. Stores. There's a place I'll show you how it's storing. Storing it twice. Storing it twice. You can see here. You can see here. At this point, I said, let the elements from the multiplicative group elements. Multiplicative group. You see, multiplicative group is the group, this group. The one which had listed the elements which are relatively prime. Is that okay? That is that group. The one which has a list of only those which are relatively prime. So this one is referring to that. It has copied those elements. It has those elements here. It has copied those elements there. So it says let the elements from that multiplicative group elements. Then it says let subgroup. Then it opens an empty vector for storing those subgroups. Is that okay? That's an empty vector where it is storing the subgroups. It's mutable. It's mutable because it begins when it's empty and then the adding subgroups as time goes by. Is that okay? So it will be mutable. Then let seen subgroups. Now this part I added there just to ensure that there are no duplicates. There are no duplicates. So this hash set, you have to put there the subgroup. Before you put it here. So the subgroup that is here is also here. Is that okay? So you are storing this subgroup twice. So this one is to ensure that there are no duplicates, so that when you bring in a subgroup that it already has, then it's not that this one is a duplicate. So it will not proceed to the subgroups. It will not proceed here because it's already there. Is that okay? I think you get that point. So we are storing, but you can, if you omit this part, then the cases that we mentioned, we said some elements would generate the same subgroups. So we would find that those subgroups would be repeated. For example, when 7 generates the same subgroup as 11, you'll find those two subgroups there and they're the same. Is that okay? So then you must have this hash set just to ensure that they're not duplicates. So again, it's mutable. That means it begins empty. You can see there's an empty vector there for storing, but now you'll be storing and begins by getting those elements, those groups, and so on. Now, so after it has made those conditions have been set, it begins now asking, begins asking for subgroups from that other. Now look at this. If I want to read this statement, and what I'm looking at is the sign, this symbol. That we say it means not. Now, so if the elements is not empty, if that means the elements, if the elements is not empty, this one's the one that making me say not empty. Why is that elements? The elements is here. The elements we are referring to is here. Are you getting what I'm reading? Huh? This is the elements we are reading. So it says, if the elements is not empty, what that means is that if this has elements from above, you see, this was the set of this. So it's saying, if this is not empty, if there are elements, in other words, if there are elements here, is that okay? If there are elements here. So what is saying, if there are elements here, proceed and do what is here. So it's saying, if the elements is not empty, then enter. This is a loop. So it's just telling you that if the element is not empty, then now proceed and do what is inside. Is that okay? Yes. Now let's see what is inside. Now for our case, the elements is not empty. The elements is not empty because we have elements. We have 1, 3, 5, and 7 in that set. So it's not empty. Now, so if the element is not empty, the first thing you are doing, push the elements. Remember we said that a group is its own subgroup also. Is that okay? So you see, what that one is, what this part is telling us, that if the element is not empty, then push them to the subgroup, that vector that contains a subgroup, as a subgroup. If the element is not empty, then push the elements to the subgroup here. Want to push it here. Want to push it here. But of course, I said as you push it there, you also push it to the scene subgroups. So you push it here and push it here, just to ensure that there'll be no duplicates at some point. So this is what it has said here. That's what it has said here. That's what it has said. So you're pushing it to the subgroups, and then you're also pushing it to the scene subgroups. If the elements is not empty, you push those elements to the subgroup and then to the scene subgroup. So you're pushing it here and also pushing it there. Is that okay? Good. And it's going there as a subgroup. It's going there as a subgroup. The subgroup that is the whole group. The whole group is going there. Now you are done with them. You are done with sending there the whole group. So after sending there the whole group, you now come here. It now wants to begin requesting for those which will be generated by elements. Because you know that the entire group is never generated. It's just a subgroup, but no element is generating it under this multiplicative group. Is that okay? So that one, we just know that the entire group is a subgroup. So we are pushing it there. Then you come here. What does it say? For every E in the elements, for every E in the elements. Now, these are my elements. These are my elements. Is that okay? And each of them is now being referred to as E. Each one of them is being referred to as E. Is that okay? So that is why we are beginning with that loop and saying, for every E in the elements, we enter the loop and we are supposed to perform what is inside. For every E. That means you do it for 1. After doing it for 1, you do it for 3. After doing it for 3, you do it for 5. Then after that, you do it for 7. For every. That's why it begins by saying, for every E in the elements. Remember, our elements are here. Remember, our elements are here. And we came with them from the multiplicative group above. Why is that? For every element that, let the subgroup, it's now calling for this function. It's calling for this function which is above. It's calling for this function to do what? To generate a subgroup for this E. Is that okay? Yes. So for instance, it will call, let me show you what it's calling. It's calling for which? It's calling for the one I told you, the one we've not touched. We'll come to this. Generate subgroup. Generate subgroup. That is a function being called on to do that. We're saying let subgroup. Then it calls generate subgroup. That function is calling for that function. Is that okay? Saying that function, now give me the subgroup generated by E. E for this time it will be 1. Then next it will ask for 3. So once it does for 1, once the generate subgroup does the subgroup for 1, it tells us push it or insert it to the same subgroup. So after we've gotten the subgroup generated by 1, it's inserted to the same subgroup. And then lastly, is pushed to the subgroup. It's pushed there. Is that okay? Yes. So we are done with 1. It again comes here and asks for n with 3. It asks for generate subgroup for 3. Is that okay? Once the subgroup for 3 is generated, it inserts it in this hash, this scene subgroup, then pushes it to the subgroups. Then it requests for n with 5, then n with 7, and so on. So that is how this last part will be working. That's how this last part will be working. So I've explained how each of these parts will be doing. So I just want to look at generate subgroup. How does it now generate? How does it generate? Of course, we have the main function here. We'll come and see what it's doing apart from just initializing the values. We'll come and see what it does. Now let's come to this function now. This function appears to be the one doing a lot of work because it's the one now generating the subgroups. Look at what is here, n, and the generator. The generator, just below there, we've referred them as E. Is that okay? So the one that is calling for it is calling for E, n with the E. So E is our generator. It begins by letting the subgroup be empty. it's empty. Is that okay? Then let the current be the generator. Let the current be the generator. I just want to show you how it will then be coming up with the subgroup. Is that okay? Yes. I'm doing it mode 8. Doing it mode 8. And it has been asked to get the generator, the subgroup for, let me say 3, generated by 3. The one generated by 3 wants to do that. So what is it doing here? What is it doing here? At this point, it's saying the subgroup is empty. Is that okay? Subgroup is empty at this point. The current is 3, the generator. Is that okay? The current is the generator. There's a loop. There's a loop. And the loop says, while the subgroup does not contain, is this symbol here. While the subgroup does not contain the current. You're seeing what I'm reading, is that okay? Huh? While the subgroup does not contain the current, then you enter inside. Remember, we began with a subgroup which is empty. Here, the subgroup is empty. Our current is 3. While the subgroup does not contain 3, which is the case now. Is that okay? That is the case now because our subgroup is still an empty vector. Is that okay? So it's our case. Now it says, push the current to the subgroup. Is that okay? Push the current. While the subgroup does not contain the current, push the current. Is that okay? To the subgroup. So if the current is not in the subgroup, push it there. So it means if the current is in the subgroup, you don't push it there. Is that okay? You only push it there when it's not there. And again, that is to avoid having duplicates. Just to avoid duplicates. That is why we have that part. While the subgroup does not contain the current, push the current to the subgroup. So we wanted a subgroup generated by 3. We are pushing 3 there. We are pushing 3 there to the current. Is that okay? Then it says, after pushing, come up with another current. And that other current is the old current times the generator. Then you divide by n and write the remainder. Is that okay? That's what this part means. That's what this part means. So our current was 3. We pushed it there. We now come up with the new current. The new current is the old current times the generator. Our generator was again 3. Our generator was again 3. That is 9. Is that okay? Divide by n, which is 8, and write the remainder. So our new current is 1. Is that okay? Our new current is 1. You come back here. And at this point, the statement says, while the subgroup does not contain the current, push the current to the subgroup. So we push our current there. Push our current there. Is that okay? Good. After pushing it there, we come up with another current. Now current is the old current times the new current, not times the generator. Generator is 3. Times the generator. Generator is 3. Is that okay? The answer you get there is 3. Divided by 8, the remainder again will be 3. This current is already in the subgroup. So you don't push it there. You exit the loop. You exit the loop, and when you exit the loop, what you have is the subgroup. What you have is a subgroup. So you exit the loop. So once this one gets the subgroup generated by 3, this one, as we've explained, takes that subgroup, pushes it inserts it here. No, not here, it's here. The scene subgroup, and then pushes it to the subgroups. And that process continues. That process continues. Unless somebody has a question on how this code works. How it works to perform its roles. Have you understood how it's working? Is that okay? But again, the good thing is that those videos, you just listen to them. Let's look at what the main function will be doing. The main function, the first thing is doing, you insert the values, your initial values that you want, you can replace. Then it calls for generate all subgroups to give it the subgroups. That function, generate all subgroups. Generate all subgroups is this function. So this is the one the main function is calling for. It's calling for it to give it the subgroups. And then this one begins what we were saying. And then it calls for generate subgroup, which is above. Is that okay? Yes. So this one is just calling for generate subgroups function, all generate all subgroups. Then once it gets all subgroups, it's supposed to print them. It's supposed to print those subgroups. So those are the roles it's performing. Okay, so let me now share the code that we look at it. There's a minute. Okay, here the code is the code. So I put here 8. I want the subgroups generated for Z star 8. Those are the ones I want. Just given me all the subgroups. The first one is the entire group. Then we have these other groups, subgroups. Those are the subgroups. Can you increase it a bit to, let me see, 18? Z is 18. That's what it gives us. Gives us the subgroups. Of course, it begins by listing the elements which are relatively prime to 18 as one of the subgroups, then gives us the other subgroups. Okay, this don't want a very huge number because it might take time to give us the results. Let me try 38. Begins by listing those which are relatively prime to 38, and then gives us the other subgroups. Of course, these elements are many, but you can see the subgroups are less because of what we explained, that some elements would generate similar subgroups. Is that okay? And so because of the hash set, it's avoiding that repetition. You don't need to have subgroups repeated. Let me try 380. Again, by listing the elements which are relatively prime, there are so many. Begins from 1 here and ends where those which are relatively prime. Can't see where it's ending because it's a long list. Or it ends at 379. These are the elements which are relatively prime. Ones highlighted here, relatively prime to 380. 379 is the last one. Then from there, this again, the highlighted becomes the entire group. The entire group is the one highlighted. Then the other ones generated by the other elements are the ones you now see. The other subgroups generated by the other elements. Now, I've already explained how this code works. And I'd already included the notes. You can look at the notes later. I just explained what I've already explained. The use of this hash set is just to avoid duplicates. And then the GCD, I said we compute the GCD for all the elements mod n. All the elements mod n. And I had in fact given an example of how it will be computing that GCD. Then after computing the GCD, we say that this function now picks only those which are relatively prime to n. And that we see it from where I'm underlining. Those which give the GCD of 1 is what this function now is just picking from above. From above function just picks those elements which are relatively prime, and those are the elements which form the group. Those are the elements which form that multiplicative group. After that, its role is done. Then it remains the role of the other functions. But before this, we have generate all subgroups which are below the one that is now asking for this to perform its role. Because you see, how does the work, how does it begin? It begins at the main function. It begins at the main function. So the main function begins by asking, generate all subgroups function. Generate all subgroups function. And generate all subgroups function is here. Now generate all subgroups function calls for generate subgroups function. Generate subgroups function, and generate subgroups function is here. Is here. Now, apart from calling on that, it also calls on multiplicative group elements. It also calls on multiplicative group elements. And the multiplicative group elements is here. Is here. And the multiplicative group elements calls for the GCD function, which is here. So this is the one who is now doing the GCDs. This one picks those which are relatively prime. So that is how it works. It begins with the main function calling on that, then that one calls on the next and so on, so that they are working together. Now, I've already explained how this generate subgroup function works. I said it begins by letting the subgroup be immutable and it gives an empty vector for storing those subgroups, the subgroup, elements of the subgroup. Then the current becomes a generator. Then while, and I said this, we read it, while the subgroup does not contain the current. That's how you read that statement. While the subgroup does not contain the current. This is the subgroup. So you see it's empty. The current you're making the generator. So when you make the generator the current, that generator is no longer here. It's not here. So while it's not there, it's saying push the current to the subgroup. Push the current to the subgroup. So since it was not there, push it there. Is that okay? Then calculate the new current by the old current times the generator. Then divide the result by n, write the remainder. That becomes the new current. And while this new current, again, is not in the vector, push it there. Here. While the subgroup does not contain the current. So you calculate a new current. You've calculated a new current. So while the subgroup does not contain that new current, push that new current there. And when you find that the new current that you have is already there, you don't push it. You don't push it there. You exit the loop. So that is how this part is working. Yeah, some of these things, these symbols, if you know what they say, it becomes very easy for you to work on these codes. Now, generate all subgroups is here, and I've already explained what it does. I've already explained that first of all, it calls on the multiplicative group elements function that gives it all those elements that make that group. And then let mutable subgroup. It opens that empty vector for storing the subgroups. Then there's this same subgroups hash set. And I say what hash set does. Then it says, if the elements is not empty, if the elements function, if the elements is not empty, the elements is here. This is the elements. If the elements is not empty, is how we read it, is how we read that. If the element is not empty, then you proceed here push the elements to the subgroup. Push the elements to the subgroup. Then insert the elements in the seen subgroups. Is that okay? Yes, insert it. Once that is done, and it says here, for every E in the elements, they'd explain what E is there. For every E in the elements, let the subgroup, then it calls for the generate subgroup function. It calls for generate subgroup function, gives it E to generate the subgroup generated by E. So it gives it E to give it what subgroup E generates, and so on. So that is, they already explained those ones. And the main function again, we already explained what it does. Now, so this part I try to break it down so that somebody can understand. I've broken it back, broken down into several parts. So here, at this point, I try to just look at these three, what they mean, first of all. What these three mean. Let that, and what they mean. And I've written there, let elements multiplicative. So this one, I've said it's calling on that to give it the elements for this group. The elements for this group. Then we have this part, and again I've said what it does. So it creates an empty vector for storing the subgroups. Is that okay? It's just a creation of that empty vector. Then this one again, a creation of this empty vector, the hash set that will be ensuring that there are no duplicates. And that's what I've explained here, that this ensures each subgroup is only added once. And then I broke it into this other part and what it means, this part, and of course, I've already read this as if the elements is not empty, and so on. Okay, thank you. Unless somebody has a question. If there's no question, we stop there for some time. Then we meet after a few minutes. We see what to do after that.